In 3.5, we're going to talk about complex zeros and the fundamental theorem of algebra. We have reached the fundamental theorem of algebra. The reason for algebra is this. If p of x is a polynomial of degree n, where n is greater than 0, then p has at least one 0 in the complex numbers system. That can be real or that can be imaginary. There's always a solution. But keep in mind, it can be real or it can be imaginary. So now we can find all zeros. Multiplicity. If a factor or zero appears more than once, it is said to have multiplicity. We talked about this in previous sections. So let's take a look at these examples and talk about, let's factor them and find out if they have multiplicity. X squared plus 4x plus 4, that does factor into x plus 2 and x plus 2. So does this have multiplicity? Yes, it does. And what is the multiplicity? It's an even multiplicity of 2. Two of the same answer. X minus 3 cubed is x minus 3 times x minus 3 times x minus 3. These are called linear factors. So does it have multiplicity? Yes, it does. Of 3. 3 of the same answer. And for the last one, I can simple factor out x squared, and I'd be left with x plus 2. Does this one have multiplicity? The answer is yes. It actually has a multiplicity of 2 because of the x squared. So yes, it does a multiplicity of 2. Now, we're going to use a bunch of different things to be able to solve these in factor, using factoring, completing the square, quadratic formula, factor by grouping, anything, P over Q. These are all different ways that we can find the zeros. Okay, let's look at a few that are factorable. Here are the steps for finding zeros. Is the function factorable? That would be the first thing I checked. If not, then it could be plus or minus P over Q, synthetic division, and then factor, completely factor. Remember multiplicity of factors. Okay, first example. Find all zeros, real and complex, state their multiplicity, and factor completely. So first thing I'm going to do on example 1 is I'm going to factor. It actually is factorable. It factors to x squared plus 5 and x squared plus 5. All right, those are my two factors. Now I'm going to set my factors equal to 0 to find the zeros. X squared plus 5 equals 0, and x squared plus 5 equals 0. This will give me my linear factors. Subtract 5, x squared equals negative 5. Take the square root plus or minus of both sides, and you will get x equals plus or minus I root 5. There's that answer. Now, obviously, the other factor is exactly the same, so we'll also get that over here. So x equals plus or minus I root 5. So now take a look at what I have. What are the zeros? I have a positive I root 5, and I have a negative I root 5. All right? Do they have multiplicity? The answer is yes, they both do. All right, if you look at it, one has a positive answer and a negative, the other one has a positive and negative answer. Yes, they have multiplicity of 2. Great, now we can put the completely factored form of the product of our linear factors. Here we go. All right, so we have our factors. I use the zeros up here. Here we go. So our factors are, I'll do the positive ones first. So x minus I root 5. And I have a second one because there's multiplicity of 2. X minus, it's always a minus, I root 5. And the other one, it's the negative I root 5. So x minus a negative, it's always minus, remember. X minus a negative will give me x plus I root 5. I got one more, hard to fit there, x plus I root 5. You can also write this as x minus I root 5 squared, there's two of them, and x plus I root 5 squared. Either one of these answers is okay. Let's do one more that is factorable. All right, on this one, I can factor out an x cubed, and I'm left with x squared minus 3. set it equal to 0. So x cubed equals 0. X squared minus 3 equals 0. Add 3 to both sides here. Take the square root plus or minus. Now we'll get x equals plus or minus root 3. And here, if I solve this, take the cube root of both sides, I'll get x equals 0. The question is, what are the zeros? I have 0. I also have a positive root 3, and I have a negative root 3. All right? Is there multiplicity? So for 0, yes, there is. Different color here. Yes, there is. There's 3 of those, right? Because it's x cubed. There's 3 of those. Is there multiplicity for the positive root 3? Nope, there's not. There's only 1. And for the negative root 3, nope, there's not. There's only 1 of each of those. There's no multiplicity. The product of the linear factors, technically, you're going to have 3 x's. I'm going to clean this up. There's x times x. And then I have x minus root 3 for this one. And x minus a negative root 3 is x plus root 3 for this one. I can clean that up. I don't need to put x times x times x. That would just be x cubed times x minus root 3 times x plus root 3. All right. Here's 2 examples of where the function was factorable. Now we're going to look at a few different ways in the next videos when they're not factorable and what we should do.